Hello out there and welcome to Peter's online tutor. Today we shall be looking at physics and the topic on the board is conversion of galvanometer to voltmeter. Now there's a past question, okay, on the board, past question in physics. Now it reads, a milliammeter of resistance 5 ohm and full scale deflection of 50 milliampere is to be used to measure a potential difference of 50 volts. What would be the resistance of the multiplier? Now, before I go on to solve this particular question, I want us to take note of the following points. Now, look at this diagram, okay? If you are trying to convert a galvanometer to a voltmeter, all right? Now, this diagram explains it. The galvanometer, all right, is connected in series to a high resistance wire known as the multiplier. Okay, so you can see that what the galvanometer and the multiplier are connected in series. Apart from that, current is the same. Okay, so the current across the galvanometer is the same current across the what? The multiplier. And apart from that, potential difference is not the same. Okay, so they do not have the same potential difference, but they have the same what? Current. And take note, the resistance of the multiplier is what? High. Now, let us go on to solve this question. Now, if you look at this question, okay, let's see, since I was in series, okay, now the first point here is Ig is equal to what? Im, okay, and apart from that, if Ig is equal to what? Im, it shows that the total potential difference, that's V, is equal to the potential difference across the galvanometer plus the potential difference across the what? The multiplier. All right, okay, so let us take note of that. All right, now from here let's now go on to solve this question. A milliammeter of resistance 5 ohm. Now they use a galvanometer here, so we can use a galvanometer here in place of the what? Of the milliammeter. So from here our Rg is equal to what? 5 ohm. Okay, now and a full scale deflection of 50 milliampere. All right, so that means our Ig here is equals to 50 milliampere. All right, now is to be used to measure a potential difference of 50 volts. Now this 50 volts here, okay, is the total what? PD in the what? In the circuit. So our V here equals to what? 50 volts. Okay, now we are now asked to find the resistance of the multiplier. This is what? Unknown. All right, so looking at this, okay, from what we are having here, take note of the fact that my Vg is equals to what? Ig Rg, okay, from Ohm's law, and then my Vm is equals to what? Im R what? R what M, sorry, R what M. Now, from what we're having here, if we come back here, it shows that since our Ig is equals to what? Im, Ig equals to what? Im, okay, now our Ig here will be what? Vg over what? Rg. So we're having Vg, that is the PD across the galvanometer, over what? Rg, that is the what? The resistance of the galvanometer. Okay, the galvanometer or the what? Or the milliammeter, I beg your pardon, the milliammeter. All right, now it's equal to my Im here, okay, equals to what? Vn, that is a PD across the what? The multiplier over what? R what? M, that is the what? The resistance across the what? The multiplier. Now, if you take note of this, our Vg, okay, that is the voltage across the what? The galvanometer or the milliammeter. Of course, we can solve for that, so you can see that is given. Our Rg is given. Okay, now we don't know our Rm, okay, and then we don't know what? Our Vm also. Now, from here, what do we do? Now, let us get our Vg first. Let's try to get our Vg. Okay, so our Vg here is equal to what? Ig Rg. Okay, so Vg now is equals to our Ig here is this, that is 50 milliampere. So you divide it by 1000, okay, now times our Rg, which is what? 5. Okay, so by the time you cut this and this, you're having 25 over 100, that is 0.25 volts. Okay, now let's now get our Vm. So come back here. From here, we have that V is equal to what? Vg plus what? Our V now is 50. Our VG is 0.25 plus what? Vm. All right. Now this can come here. Our Vm now equals 50 minus 0.25. Okay. Now that gives me my Vm as 49.75 volts. Okay. So our Vm now is what? 49.75 volts. That is what the PD across the what? The multiplier. So with this now, let's see what we can do here to get what our R what? Our Rm. Okay. Now let's come back here. Come back here. And what we are having here, it means that my Vg over Rg, okay, Vg over Rg equals Vm over Rm, Vm over Rm. Now my Vg is given to me as 0.25. Vg is 0.25 over my Rg. My Rg is given to me as 5. Okay, that's 5 equals my Vm is 49.75. 49.75 over, okay, my Rm. My Rm is given to me as that's the resistance across the what? The multiplier, okay, is what I don't know. I'm looking for it. You can see that I'm looking for it, okay, so I'm not given, so that's what I'm asked to find. Now cross multiply. Rm times 0.25 equals 5 times 49.75. Both side by 0.25, both side by 0.25. This cancels this. At the end of the day, our Rm now is equal to, now 5 times 49.75 over 0.25 will give us 995 ohms. So like I said before, I said the resistance of the multiplier is high. All right, so that is what I answered. All right, if you love this video, please click on the subscription button and like this video.